All right, our last chapter are human impacts, and the one we're going to cover in this slideshow is climate change. Okay, so climate change, we're really going to talk mostly about the evidence for climate change, and we'll talk about how humans have caused climate change and how scientists measure the atmosphere, temperature, and climate. And so there I've got a picture of one of the best pieces of evidence. That's the Columbia Glacier, 60 years apart, retreated something like 15 miles, and now there's a lake where it was. And so we're looking at evidence of a change in climate, and a change that's um, out of the ordinary, something not seen before. And so we're going to describe some of the things about that. And one of the first things I want to talk about is that there's often a lot of confusion about climate. And people get confused with weather versus climate. And weather refers to day to day temperature and precipitation in an area. It's something we watch, and it's concerned with seasonal change, daily variation, and things like that. Whereas climate refers to long term patterns and variations of temperature, wind, humidity, air pressure, and precipitation in a given region. Okay, climate, in this case, we're talking about the climate of the whole Earth. And so we're really not talking about a weather map or what happens today or next week, but what is the pattern year after year? What are the long-term patterns and how are they varied? And the good news is we have lots of data going back at least 150 years in some places, in other places even longer. And so we can compare records of temperature, precipitation, air pressure, and so these are, we have a good data set to compare this. Okay, when we talk about climate, we have to remember that there are really three big factors that shape climate, and to shape what weather patterns are experienced in a region. One of the big things is incoming solar radiation. Solar radiation provides the heat that drives climate. Okay, areas that receive more solar radiation are warmer, uh, but solar radiation also has some other effects. One of the big effects is that the ocean has a huge impact on climate. The ocean in some places is 20, 30,000 feet deep. It can absorb huge amounts of heat. It releases heat as well. Evaporation from the oceans is carried by the atmosphere into other regions, and that's the origin of most precipitation. And so the oceans play a big role in climate, in moderating climate, and in sending humidity and precipitation in other places. The other really big effect is the greenhouse effect. And this is an effect whereby gases in the atmosphere trap heat. They prevent heat loss that normally occurs at night, and so this keeps the climate warm. Okay, these gases absorb heat and re-radiate it back to Earth, and they prevent it from being radiated to space. Okay, there are several greenhouse gases, notably carbon dioxide, water, methane, ozone, and chlorofluorocarbons, which we just call CFCs. Okay, the balance between incoming heat and heat loss is determined by the amount of greenhouse gases. Okay, and these greenhouse gases are rising. Okay, the levels of these are rising in the atmosphere, uh, because we're using them and releasing them. Okay, the evidence that climate is changing is pretty substantial, and um, it's sometimes confusing to lay people. Most often, people talk about air temperatures and say, "Well, we had a really cold winter. The climate can't be changing," or "It's so cold today, I can't believe they're talking about global warming." And really, air temperatures are extremely variable. They vary seasonally and they vary with weather systems. Um, and when we talk about air temperatures, we have to realize we're talking about evidence of air temperatures over large regions. And so it's a difficult thing to talk about. However, there are some indicators of climate change that are much better, that are much easier to see. These include sea level increase, ocean temperature and pH, shrinking polar ice caps, loss of mountain glaciers, lake temperatures, permafrost loss, soil temperature increases, among others. And so, you know, there's a picture of the polar ice caps. Let's go through these. Okay, first of all, climate change evidence and climate evidence. Where do we get it? Well, atmosphere evidence on the atmosphere composition and temperatures come from direct measurements. We've been taking these direct measurements very precisely for about 70 years. So we have very good measurements of the gases in the atmosphere going back that far, and that's nice. But we can go back even farther. We can measure the gases in the atmosphere that were present before historic times. And how do we do this? We use cores to bore deep into glaciers or ice layers at the poles, and we can measure air bubbles that were trapped in these ice layers for the amount of carbon dioxide in them, for oxygen isotopes, which can give us the average temperature of the atmosphere. And we can see lots of other things in these layers. These layers go back over 700,000 years. And one of the things these things tell us is that fossil fuel burning is rapidly changing the composition of the atmosphere. We've almost doubled the level of carbon dioxide in the atmosphere. It's one of the most powerful greenhouse gases, and so we expect that this might have an effect. And when we go back and correlate levels of carbon dioxide with temperatures, we see that there's a correspondence. Periods of low carbon dioxide correspond to lower temperatures that occurred during the ice ages, and higher levels of carbon dioxide correspond to warmer temperatures that were experienced during interglacial periods. This is really good evidence, and it's evidence that's corroborated from ice layers from different glaciers and in different regions of the world. Okay, even more important, I think, are levels in ice and ocean levels. And sea level has been rising. Okay, sea level rises during warmer periods because as water heats up, it expands, and because melting glaciers add their water to the ocean. And so if sea-based or if land-based ice melts, that adds water to the ocean. And we have a very good record of sea level because we can look at past shores, and so we can find buried, um, you know, times when the ocean was higher because we can see evidence of that, and we can also see evidence of when it was lower. And we see rapid warming of the oceans has led to sea level change. So this is a really nice additional piece of evidence. Another piece of evidence is that sea ice in the Arctic has decreased rapidly. That we have very good records of this, partially from the U.S. Army, partially from polar explorers. And just in the last 35 years, the area of sea ice has dropped by almost 50%, and the volume has decreased almost by 2/3. That's evidence of a warmer Arctic Ocean. We can also look at things like ocean temperatures. The Greenland current is a half degree warmer than it was just 40 years ago. That's a huge increase in heat. Likewise, we can see these kinds of changes in water temperature reflected in the temperature of lakes. Lake temperature reflects regional climates, but the lakes aren't so variable. They don't fluctuate as much. And so a big lake like Lake Superior only fluctuates a few degrees in a year, but over time we can we can see, oh yeah, the temperature of the lake has fluctuated, and most lakes have warmed. In addition, we can also look at land-based ice, okay, glaciers. These glaciers are found in mountain and northern regions in North America, and they can easily be tracked. And we find that over 95% of North American glaciers are shrinking. Some are shrinking rapidly. When we look at the same land based glaciers worldwide, we find the same picture, whether it's Europe, Asia, Africa. Uh, Land based glaciers are shrinking because of climate change, warming. Another uh, factor or another piece of evidence that indicates warming is soil temperatures and groundwater temperatures. Soil and groundwater temperatures again reflect regional climate. Solar radiation, air temperatures, temperature of water running through it, and we find soil temperatures are rising. And in areas where soils were permanently frozen, like Alaska, we find that these permanently frozen soils are no longer frozen, that they are no longer permafrost. And so this is another piece of evidence. And altogether, we have lots of lines of evidence that all point in the same direction from different parts of the world, all saying temperatures are rising and rising fairly rapidly, and that this rise is historic and associated with carbon dioxide. Okay, well, I want to talk a little bit about complex problems because this sounds horrible. It's depressing. It just, you've got this big problem based upon how we used energy. Well, this is a complex problem. Okay, this has not come about overnight. We've recognized this 30 to 40 years ago, and so this has developed slowly as uses of fossil fuels have increased worldwide. And it's not just fossil fuels. There are other things involved. The release of methane from agricultural activities or increased usage of methane, the production of chlorofluorocarbons and ozone. These things also matter. And so there's multiple causes, and it's a problem that's developed over a long period of time. And it affects many people worldwide, not just Americans, not just consumers. It affects producers. There's many, many stakeholders. We shouldn't expect to be able to fix this overnight. Okay. On the other hand, to throw up our hands to say it's not fixable is not realistic either. Okay, there are ways to solve big problems. Okay, and you have to be methodical. You have to go about it, plotting and working at it. You identify the causes of the problem. You identify possible courses of action, analyze the costs and the benefits to find which courses of action are the best, and then develop a plan and implement it. It's important to know where we're producing carbon dioxide. Is it cars? Is it electricity? Is it industry? Is it residential heating? It's important to realize where these costs, where this production are, how will we change these things, which gases are most important. It's important to go about this. Clearly, carbon dioxide is the main source. Clearly, there are ways to go about addressing this. Okay. And actually, it's not hopeless. It's actually happening now even without government action. We can reduce carbon dioxide emissions, and doing so is not painful. In fact, it's actually helpful. We can do this by improving energy efficiency, using hybrid cars, using electric cars, using LED lighting. Okay, energy consumption in the United States is falling. Okay, it's falling because people are adopting some of these things even without being forced to. LED light bulbs, okay, like the light bulbs show there, cost a little bit more, but they use 95% less electricity. Okay, they last 10 times longer than conventional light bulbs. Okay, Yeah, they cost more to change, but once you've changed, you're going to save a lot of money and you won't have to be changing light bulbs all the time. That's really cool. Okay, and doing so is dramatically lowering energy costs. We're doing this here at the college. We're going to save over $500,000. Likewise, that's my 2003 Honda Civic Hybrid. When I bought it, it seemed like a risky move. It had a battery in it. It had regenerative brakes that would generate electricity every time I was braking. It cost me another $2,000 more than a regular Honda Civic. Well, my goodness, now it's 15 years later. I drove 175,000 miles in that car. It averaged over 50 miles to the gallon. I saved thousands. It was the best car I ever had. I never had to replace the brakes. I never had to replace the battery. Never had to replace the exhaust system. It was the most economical car I ever had. I saved a fortune. Okay. A lot of these things, a lot of these solutions are like this. They're win-wins. Everybody wins. The environment wins. The consumer wins. Highland Community College is going to install solar panels. Okay. It's good for the environment, but that's not why we're doing it. We're doing it because we're going to save money, lots of money. And we're going to install more solar panels. It's a win. The people that are complaining most loudly about climate change, they're going to lose because they're the oil producers, the gas producers, the coal manufacturers. Okay, but we can solve this problem. It's not a big one. All right, we'll stop there, and next week we'll talk about the biodiversity crisis.